The indirect function, once explained, is the simplest of the reference functions to understand, but can still be very challenging to use. The indirect function converts a text value into a reference. That's all it does. Very simple and very powerful, but still quite confusing. Let's take the example from our last lesson and replace all of our references with an indirect function. To do this, I will replace A1 with indirect A1. The A1 is in quotation marks because I want it treated as text instead of as a reference. I can do the same with B1 and with each of the others, and my formula result will be unchanged. Technically, I'm doing the exact same thing with the indirect as I would have otherwise, so this does seem kind of useless, but let's go another step. Now I'm going to type A1 into cell D1 and B1 into cell D2. Within my indirects, I'll replace the A1 and B1 in quotations with references to D1 and D2. This still seems like we're going out of our way to do something easy the hard way, but perhaps you're starting to see the future value. What if we broke the components out some more? I can change D1 to A, E1 to 1, change D2 to B, and E2 to 1. I can modify my indirect to reference D1 and E1, and do the same for the D2. In this way, I'm concatenating the two cells together to generate a result. You may still be asking how this could possibly be valuable. We've taken a really simple thing, A1 plus B1, and turned it into a monstrosity that is terribly hard to read, terribly confusing, and provides no additional value yet. So let's use the indirect function to replace a monstrosity with a simpler formula taking advantage of these properties. We're sticking with the same general concept here. We're using the values in A1 through B2, and we want some combination of those values, except now we have a nested if statement and it's kind of ugly. When C1 is 4, we want A1 plus B2. When C1 is 3, we want A2 plus B1. When C1 is 2, we want A2 plus B2. And when C1 is 1, we want A1 plus B1. Basically, we want 4 different sums depending on what the value is in C1. This is a case where simplification through breakdown could be helpful. We want cell B2 if C1 is 1 or 4, and B1 otherwise. And we want cell A2 if C1 is 1 or 3, and A1 otherwise. That's 2 fairly simple if statements. In cell D1, I can type if C1 is equal to 3 or 1, return A2 or A1. If you're unfamiliar with the OR statement, it simply returns true if either one of those evaluates to true. I can do the same thing in D2, except my C1 will equal 1 or 4. Now I can type equals indirect D1 plus indirect D2, and I'll get the exact same results as with my nested if statement. You might still not be sold on the function, so we'll move into a bigger and more realistic scenario that uses the power of well-formed name ranges to our benefit. This file should look familiar, as it's the solution to exercise 3 with a few additional changes. I've added the type of sale below the referral code, and there is a new tab called Referral Details. The sale type indicates which type of cost of goods should be used from the Products tab, with 3 options being presented. So let's start there. The first option is the normal cost of goods. The second option is the wholesale cost of goods, and the third option is the foreign cost of goods. Each one of them has a workbook level name: J normal cost of goods, J wholesale cost of goods, and J foreign cost of goods, following the same convention that I followed with the solution. Over on the Referral Details tab, there is a singular table with 3 entries. Each has 3 columns explaining the details of what the referral code means. On this tab, I'm using a different naming approach. Rather than naming each column, I will name each row. I'm going to use the referral code itself for my naming convention so that my names will be RDRF001 through RDRF003. I can use the Create from Selection to do this quickly. These names are not immensely useful in a vacuum, so I've not bothered with the lowercase letter naming convention. This will simplify a formula later on, though. These 2 groups of names will give me a pair of ways to utilize the indirect function as an example. So let's go put it into action on my Sales Report tab. There are 2 places to update now. The first is the cost of goods calculation, which I've added a supporting calculation to the right to calculate the cost of goods name. This is a fairly simple calculation that can say, if the goods type calculated in D is foreign, it is Y foreign cost of goods. If it's wholesale, Y wholesale cost of goods, and Y normal cost of goods otherwise. I can do this using a simple concatenation like equals Y and local sale type and cost of goods. This is where good name making comes in handy because otherwise I'd need a nested if function to determine which of the 3 names I needed. I don't currently have a lookup for the type of cost of goods, however you could. Instead, it is simply a drop-down that offers each of those types. I now have a field that calculates where my data needs to come from for the cost of goods field. I'm actually going to give this field the name local cost of goods and make it worksheet specific. Now I can modify my cost of goods formula to use indirect local costs of goods instead of Y cost of goods. The formula is not quite as clear as it once was, however it is now more flexible by packing 3 different scenarios into a single function. Switching between the 3 types of sale gives me 3 different calculations for the cost of goods. Let's break the function down just a little bit further now. If I dive into the formula and select local cost of goods and press F9, I see that it evaluates out to the name of the range that I want to look at. As we understand, the indirect function converts the string into a reference. That's as good as entering that reference into the formula itself. The difference is that now we have taken what would have otherwise been a nested if with 3 different index functions, and we've used an indirect function instead. This is a vast simplification over what the formula, now shown on your screen, would have looked like using the if statement. Now how about that referral code? This example is actually going to be even simpler than the last. Since we only have 3 referral codes, we're never even going to perform a match. Instead, we're simply going to calculate the name of the row that we're interested in, something we've actually already done. And since we want all 3 entries anyways, we're just going to pull that entire row. In this little table below our results, I'm going to write the function equals index indirect local referral code 1. If I had used the lowercase leading letter convention, I'd need to make the formula include that concatenation, which makes it a little bit more difficult to read without providing any significant value and understandability. I can copy this to the next 2 cells and change the 1 to 2 and 3. And if you're familiar with array functions, I could have used a single array function like so to get the same results. But that's a little bit beyond the scope of this course. So now what is this doing? Well, I know that each type of referral code has a name associated with it, so I'm using that name to directly access the range that I'm interested in. This approach is great for small tables that you want to index into with clear and unique codes. In essence, I'm using indirect plus a set of named ranges to replace the index and match function. If you're familiar with coding, this is similar to using a hash table. Hopefully, you're starting to understand the power and flexibility that the indirect function can provide. I use this function fairly frequently for handling various intersections of data when I need to be able to quickly and easily modify my view. However, there is a fairly significant drawback to using the indirect function. The indirect function is a volatile function. Volatile is a technical term that means that no matter what, the function must recalculate itself, and any cells that refer to that cell must recalculate themselves every time that Excel recalculates. If you remember our discussion on index and match, they help improve Excel's performance by limiting recalculations comparatively to the VLOOKUP and HLOOKUP functions, while indirect does the opposite of that. What this means is that ideally, you should try to use indirect functions and other volatile functions at the end of your calculation trees rather than at the beginning or in the middle. In our example here, we've used the indirect function at the very end of our referral details tree, as there are no cells that depend on those calculations. But for our costs of good tree, we are not at the end, but towards the middle. The implication is that even if you don't change a single cell in the workbook, every time Excel decides to recalculate, it will recalculate the cost of goods column. That means that the total cost column will also have to recalculate, which means that the net profit calculation will have to be redone, as will the total calculations. That is a bunch of recalculation for absolutely no change. Heavy reliance on the indirect function can quickly turn workbooks into calculation nightmares, so use them only when they are truly the best solution to your problem. That covers effectively everything there is to know about the indirect function. The only way to truly figure out when and where to use it will be through extensive practice and experience. Our next lesson will address the offset function, which works something like a mix between the indirect and index functions.